Hi folks, welcome to another set of ICP video notes. Today we'll be talking about Newton's third law, which is also known as the law of actions and reactions. So first off, what is Newton's third law? Newton's third law states that for every action there is an equal and opposite reaction. You might be thinking, what does that mean? That means that when one object exerts a force on another object, that second object also exerts an equal force back on the first object. Those forces are the same amount of force, but they're pointing in opposite directions. That still might be a little bit confusing, so let's look at some examples. How does a fish propel itself in water? Think about that for a second. The fish wiggles his fins back and forth. When the fish wiggles his fins back and forth, it pushes back against the water. So doesn't the water just move backwards? Why does the fish move forwards too? Newton's third law has that answer. If we didn't have Newton's third law, the water would just move backwards and the fish would stay where it's at. But since we have Newton's third law, the force that the fish pushes on the water with gets pushed back on the fish by the water. In other words, the fish's fins are pushing backwards on the water with a certain amount of force, and that water pushes forwards on the fish with the same amount of force. Notice one's pushing backwards, one's pushing forwards. It's just an equal amount of force, and that allows the fish to move forward. Okay, so this works forwards and backwards, but what about up and down? Think about a bird. When a bird flaps its wings, it pushes downwards on the air. Newton's third law says that the air pushes upwards on the bird's wing with the same amount of force. This allows the bird to fly. How about a rocket engine? When an engine burns its fuel, it pushes out exhaust going backwards. Since that exhaust is being pushed out backwards, the engine gets pushed forwards. And this allows the rocket to move. One last example, I promise. This one might be a little bit more relatable to you if you haven't quite gotten it down yet. When you're driving your car, you push the gas pedal forward and the tires move. And when the tires rotate forwards, they push backwards on the pavement. The pavement then pushes forwards on the car. So the car moves forwards because the pavement is pushing it forwards, but what happens to the earth? Does the earth move backwards? Not really. If you think about Newton's second law, remember, F equals ma. So if we have the same amount of force being pushed on the car as we do the road, which, by the way, is attached to the earth, then the car, being much less massive than the earth, is going to accelerate a lot more than the earth does. The earth has so much mass, its acceleration is so small that it's basically zero. Now, if you were listening closely, you might have noticed that all four of our examples had a hidden pair of statements. So in the first one, we had the fish pushes water backwards, and the water pushes the fish forwards. For our second example, we had the bird's wings push the air downwards, and the air pushes the bird's wings upward. We had the rocket engine exhaust gets pushed backwards, the engine gets pushed forwards. And lastly, the car tiles push backwards on the road pushes forwards on the car. These are what's called Newton's third law pairs, or the third law paired statements. They are two statements, or a pair of statements, that describe how two objects experience Newton's third law. So the object that is doing the original pushing, that gives you the action force. So for example, when you push on a door, that is the action force. When you push on the door, that door pushes back on you. That's the paired statement. You have your action force, you pushing on the door, and your reaction force is the door reacting to your push by pushing back on you. The action and reaction forces are always the same exact size, they're just going in opposite directions.